Today I want to talk to you about multiplying rational numbers and your approach on multiplying rational numbers. So for this example, 2.8 times 0.1 times 4.63. I want you to think of using the commutative and associative property of multiplication or different properties that we know to make this problem a little bit more efficient. So you can definitely multiply 2.8 times 0.1, and whatever your answer is, you multiply that by 4.63. And you will get the same answer. But for a problem like this, I know that I have this 2.8 and I have this 0.1. So I can move this decimal place over once and move this decimal place over once. Now that's just giving me 28 times 1. 28 times 1 is a lot easier number to just to use. So that's 28. Then I'm going to bring my problem 4.63. Don't forget that that 28 times 1, we moved the decimal place twice, so I can just replace those zeros. Okay? Now I'm just going to multiply as usual. So when I multiply this problem, I'm going to get 4, 6 times 8 is 48, plus 2 is 50, and 4 times 8 is 32, plus 5 is 37. Don't forget your place value, and then start multiplying. 3 times 2 is 6, 6 times 2 is 12, carry your 1. And 4 times 2 is 8, plus 1 is 9. You're going to add as usual. So I get 4, 6, 9, 12. Now, you have to count your decimal places to see where the decimal is going to be placed here. So we definitely have 2 place values here, 2 places, and 2 places here, 1, 2. So I'm going to count 1, 2, 3, 4, and I'm going to count 1, 2, 3, 4. Place my decimal here. So my answer is 1.2964. Just a way to be a little bit more efficient, work smarter, not harder. So here's another example. In this problem, I have fractions and decimals. So it is a lot easier to multiply fractions than it is to multiply decimals. So in this kind of a problem, I'm going to change my 0.7 to 7/10 because we just multiply across. So I'm going to rewrite my problem as 2 over 5 times 7/10 times 1/4. Then I just multiply across. 2 times 7 is 14, times 1 is 14. 5 times 10 is 250, times 4 is 200. And then you would simplify as usual. So it's a lot easier to change this decimal into a fraction and just multiply across in this kind of a problem. Again, we're trying to work smarter, not harder, and just be a little more efficient. Have just an open mind of how you're going to approach this problem. You don't always have to work with left to right when it comes down to multiplication. The next problem I wanted to talk about is when you have fractions and decimals at the same time. When you have fractions and decimals at the same time, fractions, decimals at the same time, but you have positives and negatives. Okay, so when you're dealing with positives and negatives. In this problem, the first thing I would do is same thing. I would change this into 3/10. So 3/10, I would change it into a fraction, 3 over 10. But I also have to remember that I have 2 negatives and 1 positive. So my answer is going to be positive because a negative and a negative is a positive. One way to look at it is we've talked about if 2 people were to agree with each other, whether it's a positive agreement or a negative agreement. So 2 people both have a negative agreement, that's a positive thing. And times another positive, your answer will be positive. So I'm going to say negative 3 over 10 times negative 3/5 times 5 over 6. And I could just rewrite it as a positive problem too. Just multiplying across, 3 times 3 is 9, times 5 is 45, and 10 times 5 is 50, times 6 is 300. And then you can simplify as usual. So 2 things to look at. Just first of all, your approach. How are you going to approach this problem? And remember, when you're multiplying rational numbers, you have to make them all one form. And I had decimals and fractions. I changed them all into one form. I changed them to all fractions. Remember your rules for positives and negatives, and work smarter, not harder.